question goes to Emma, and then we'll take Jacob's question. Emma, question number 1.
Can we go through like number 3? So I get confused like on the graphs how to figure out the logs for the graphs.
Okay. So we're looking at the position versus time graph in the learning guide, and this is actually a real nice question to look at. Real nice. Okay, so before we start, recognize that there are 2 types of motion on this graph. So that's constant, and that's also constant there, right? And then I'll make the green the changing part. So the first question is, the object's velocity illustrates Newton's first law of motion. So first law of motion is when the object is either at rest or in constant motion. So, right, this is constant, and this is also constant. And this part here is changing. So we can pretty much associate constant motion with which law? First. And changing motion with second. So that's... Does that answer question number 3? Yeah, okay. 4 and 5 are actually a little bit hard. We can come back to those in a little bit. Number 6, the object's velocity illustrates Newton's second law. So those are easy, right? Number 6 is easy. We already identified that. Number 7, the object is moving forward. So what do they mean by moving forward? So just away from the reference point, right? So is that one easy or hard? Pretty easy, right? That's pretty easy to read. The object is moving backwards. It's coming back towards the reference, so that's easy. Okay, 9, 10, a little bit tricky. 9 asks the object is speeding up. And then number 10 is the object is slowing down. So let's go back to the graph. We said that 0 to 2 seconds was constant, so it's not in that region, and it's not in the region between 6 and 10 seconds. So the speeding up and slowing down must happen between 2 and 6 seconds. All right, between 2 and 4 seconds, can anybody recognize what is happening? So going into the 2-second mark, your velocity is like that, right? It's going in the positive direction, and then it slows down all the way to v at 4 seconds. What's the velocity at 4 seconds? It's as if the object is going up a hill. It pauses and then it turns around. So at 4 seconds, what does it look like? Velocity is really 0. And then immediately after it hits that 0 velocity, what does it do? It starts speeding up back down the incline, right? Back down the ramp. We've seen that before. So this velocity is negative. All right, does that answer questions 9 and 10? So slowing down is 2 to 4 seconds. Okay, you got to remember slowing down means the velocity is going towards what number? 0. 0, that's right. Okay, so speeding up doesn't mean that it's going in the positive direction only. Speeding up can be in the negative direction. So we actually saw the object speeding up between 4 and 6 seconds. So speeding up means the velocity is going away from 0. And it could be going in the positive direction or the negative direction. Okay, so those two are a little bit trickier, but let's go ahead and check those off. 11, the object's velocity illustrates a net force of 0. Right, net force of 0 means constant motion. So we actually already answered that question. The displacement is literally just reading the graph. So between 0 and 2 seconds, what was the displacement? Displacement is final position minus initial position. So, yeah, that's 24 meters, right? What's the change between 2 and 4 seconds? So you went from 24 to 32, so the change is 8. And then how about 4 to 6? Negative 8. Okay, and that makes between 2 and 6 just you actually started at 24 meters and then you ended up at 24 meters. So your position is the same. Your final minus initial is 0. Okay, so the question was when the displacement is negative, so you're referring to part C, that is the same as going backwards, and that's correct. Okay. I'm repeating your question because my tablet can't hear you. Thank you for asking. Okay, so let's go back to 4 and 5 and finish this section. Should we answer your question first? Yeah. So to extend from Nama's question, 7 and 8. When we're moving forward, that means we're moving away from 0, which is our reference point. So that's between 0 and all the way to 4, right? Okay. And then we begin to move backwards after 4 seconds. All right. Okay, number four is actually the hardest question out of all these questions because it's asking for both the velocity and the net force. Okay. Now, the net force is only acting during what time interval? So the net force is only acting between 2 and 6 seconds. Okay, so let me just erase all of this stuff, so you don't focus on them. Okay, so the net force is only acting when you have changes in your motion. Now this shape here, this upside down curve, tells you that the acceleration is negative. So acceleration is negative during this region, and that means your net force is also negative. Alright? So the whole region has between 2 and 6 seconds has a negative net force. but that same region has a changing velocity. It changes from positive to 0 to negative. Alright, so let's answer the question. When is the velocity positive and the net force negative? The net force is never going to be positive in this problem. It's always negative between 2 and 6. So opposite, we're looking for a positive velocity. Which time interval has a positive velocity? 2 to 4. So that's really the toughest question out of all these questions. And then number 5 asks, when is the object's velocity in the same direction as the net force? We already know the net force is negative, so the velocity has to be negative. And that's 4 to 6. Alright. Okay, that's pretty much everything we need to know about that section. Next question, Stephanie. Sample problem. Okay, so let's stop this one here. Stephanie, which one do you want to do first? Number 2. Okay, so the answer is already there, so we are obviously not looking for the answer. We're looking for the method. So let's make sure you read the problem at least once before you start doing the problem. And when you start doing the problem, the first thing you should do is sketch the problem. And if it asks you to, draw a free body diagram. Okay. Now, I'm going to start listing the givens. And then maybe I'll do the FBD. It's a little bit backwards. What is this ginormous number?
353,000
kilograms. What quantity is measured in kilograms? Just mass. Just mass. Kilogram is just mass. Okay. Weight is mass times gravity. Yeah. Okay, so we just have the mass, and then the next number. The next number is actually this number here. Right? Its initial velocity is 0. And that number is more important than most people give it credit. It's actually pretty important. Okay, the number after that is 3,200 meters. And what quantity is that? Something better than distance. Okay, we want to use displacement because displacement is involved in all your acceleration equations. We have a final velocity. Okay, that's a lot of numbers, right? So you don't want to keep all that in your head. You just want to write it down. You're actually looking for two unknowns, so I'll call this unknown 1. Unknown 1 is an acceleration.